Hello, this is Eli. Welcome to another video. Today we're going to talk about queues. A queue is another data structure similar to a stack. A stack is last in, first out, but a queue is first in, first out. Queues are abstract data types, meaning a queue will enforce the operations that can be performed on it. And speaking of the operations, they're just similar to a stack. We can perform 3 operations on a queue, and those operations are called in queue, meaning we add an element to the queue, a deck, meaning we remove an element, and a peek, meaning we get the front element. So a queue is like a line or lineup. A line in a store, the first person in the line is the first person served. You can think of a real world example, I can think of a real world example of a queue as a print queue. The first job that comes into that print queue is the first job that is performed or completed. So it's first in, first out. There's no skipping when we're dealing with queues as a data structure. There's no skipping. You can't jump to the middle of the line, or you can't jump to the front of the line. When an element is added to a queue, it's added to the rear of the line. So items are removed from a queue in the same order that they're added. The common data structures for a queue, or the backing structures for a queue, are an array and a linked list. A linked list is ideal because you're always working with the front elements of a linked list. So when we add, I'm going to move this. Here's an example of a queue, and this is the front, and this is the rear. And we'll have nodes or slots for our elements. And let's say we want to add elements 5, 10, 17, and I'm just making things up, 22. So when we add an element to our queue, we add it to the front. So we'll add 5, we add it to the front. So 5 is the front. Now, if we're processing in our application, we're processing, so 5 will be served first. So we process 5 first. If we wanted to add 10, we add 10 here. Now 10 is the rear element, 5 is still the front, and 10 is the rear. If we were to add 17, 17 would now be the rear. 5 is still the front. And if we added 22, now we point our rear element to, we point our rear pointer to the rear element, which is 22. So our front now, when we serve this element, or we remove this element, we just point our new front to the next element. And depending on the implementation, you can clean up what was here. But our new front element is here. So this is how queues work. Again, they're first in, first out data structures. It's an abstract data type. And I'm just going over my notes, making sure I didn't forget anything. And actually I did forget something. So we have the NQ, which is called the add. QUEUE. And then we have the DEC. And DEC is spelled like this, DEQUEUE. And that's considered a remove. And then we have the peak, and the peak is actually what I forgot to talk about. And the peak just points to the first or the front element in our data structure, in our queue. So if we did a peak, and these are different methods. NQ would be a method, DEC would be a method, peak would be a method. So if we performed a peak, our peak method, we would point to our front element, which currently is sitting at 10. So that's all for queues as a data structure. Thank you for joining me.